This is problem 6, and I told you I would try to show you on a coordinate plane how this works. So let me see if I can make this work for us. I'm going to draw myself a coordinate plane, and I need to leave plenty of room past origin. So let's just make it go all the way over here. And I'm going to let origin be a little bit off center. So here's origin, that's 0, 0. All right, the coordinates of triangle PQR are over 1 up 2, that's P. Q is over 3 up 3. And R is over 2 up 4. So PQR looks something like this. Okay, that's triangle PQR. Then it says the triangle is translated or moved. Let me just show you. I may be messing up here, but here's what translation means. I'm going to pick it up and I'm going to move it 2 units over. Here we go. And then 1 unit down. So we're moving it from its original place. And now I can't find its original. Okay, here it is. So we're taking it from its original place and we're moving it over. That's translating. Moving it over and down. You could go this way and down. You could move it wherever you want to. But in this particular case, it says it's moving over 2 and down 1. So I need to take each point in the triangle and do that. So I'm going to start with P. It says to move it 2 places over and down 1. So here would be the new point P. Then Q, it says to move it over 2. So over 2 and down 1. So the new point Q will sit right there. And then point R, it says to move it over 2 and down 1. So the new point R is going to sit right there. So we translate it from one position to another. Now notice that it looks exactly the same. It's the same size. It looks identical because it is identical. It's just shifted over and down a little bit. So then what do they want me to do with it? They want me to flip it, and I can't show you this, I don't think. Let me try. And I tell you what, I'm going to erase the black PQR because I don't want you to get confused. I'm going to erase the letters. What we're trying to do is take this red triangle and flip it so that it is, I can't do that on this program. You can on some programs, but I can't on this one. We are going to make a mirror image of it across the x-axis. So we're going to flip it upside down across the x-axis. Let me see if I can draw it for you in a way that you will be able to see it. So remember, if we're going across x, the x value does not change. It just flips across the x-axis. Okay, let me also, because we're introducing x, y, and z, let me not do that first. One of the points would be at 3, -1. So over 3, down 1. One of the points would be at 5, -2. So over 5, down 2. One of the points would be over 4 and down 3. So do you see what I've done here? If the x-axis were a mirror, in other words, if this we'll make a green mirror. If this is a mirror, you are reflecting across that mirror. That is the reflection you see in the mirror. And so this would be point X, point Y, and point Z to make the new triangle. This is a tough question. You really have to know what those terms mean to be able to do it. And to me, it makes so much more sense if I can see it. But for some people, that is not the case. So here is the blue triangle. That is a mirror image of the red triangle. If the mirror is the x-axis, if it's the green line. That black triangle just got translated. It didn't get reflected. It just got moved. So we started here. This red step is the translation. So this is translating. And then the blue step is the reflection across the x-axis. Not an easy question. This is one of those that you could potentially just guess on if you really didn't know what those terms meant. I like this question, but I love coordinate geometry. I like it, but it is not easy. Your answer again for number 6 is C, as in Charlie.